Hello everybody, today we'll be going through basic static analysis. So to start off, we will be going through the tools that we would be using for this part of our assignment. The very first tool would be VirusTotal. VirusTotal is a free online scanning service that analyzes suspicious files to detect viruses, worms, trojans, and different kinds of malwares. The malware will be compared against a known database and also various antivirus scanners to detect and determine whether the file uploaded is malicious or not. Next will be PEiD. PEiD identifies the compiler of the malware. It also determines whether the malware is packed. It also comes with a default install plugin that allows us to unpack the malware accordingly. UPX is an open universal source executable packer which we would be using to unpack our malware later on. WinMD5 generates the MD5 hash of any file selected. PEView allows us to actually analyze administrative information of the malware and also the section information, and also to view import and export tables. Dependency Walker helps analyze the malware functionality. It also determines DLL of the malware and allows us to find relevant and important functions. Lastly would be BinText. It analyzes strings of the PE file selected and allows us to identify any interesting strings that may be suspicious, such as potential mutex name and possessors names. Yep, that's it for our tools. So as you can see, we have actually loaded the suspicious file into VirusTotal malware.exe, and we notice that the detection ratio is 49 out of 56, which means out of 56 VirusTotal scanner, 49 of them actually mark and recognize the uploaded PE file as malicious. So let's scroll down and we can see that there's a list of VirusTotal scanner that actually recognize this particular file as malicious malware. Some of them specify it as keyloggers. So Trojan. Okay, so let's continue to scroll down and we can notice that there are also various VirusTotal scanner that mark this malware as safe. Okay, so the next step would be to use PEiD to actually determine whether the malware is packed. And as we can see from here, this malware is actually packed with UPX and this particular version. The EP section is currently UPX1, and note that the malware is actually taken from this particular folder, UPX393W. So now let's use the UPX command to unpack the file. Firstly, we actually cd to desktop /UPX393W, and what we have to do is to type UPX-D malware.exe, which is the file name which we wish to unpack. Okay, so now that the malware is unpacked, let's reload it from the same folder. And we can see that the compiler is identified as Microsoft Visual C++ 6.0 and the EP section is text. So the next step would be fingerprinting. Fingerprinting can be created by hashing the malware using WinMD5. So let's go to WinMD5. Okay, so what we have to do is to just open the file that we wish to generate the hash for, malware.exe. The hash is D594E90, etc. And this is the size of it. Next, we will be looking at the unpacked version. And note that these two files has different hash, and another thing to take note is that the unpacked file is actually larger than the packed malware. To have a deeper insight understanding of the malware, we can use PEView to look at information that can be derived from the malware. So let's open PEView and let's load the unpacked malware. Look at image NT headers under image file header. We are able to look at the time date stamp, which is 2003 0514 Wednesday 162600 UTC. Next, let us open up another window and open up malware. Similarly, let's look at the time date stamp. Note that it's also the same as what we saw for the Unpack version. So let's compare. Note that the time date stamp for both the Unpack UPX and the malware.exe is the same. So we can conclude that this keylogger malware is probably created on this particular date. So now we'll actually look at the dependency walker to actually find out more about the DLL and the API that it imports. So dependency walker, and we'll open up the Unpack file. Okay. So we'll actually minimize the expanded ones. Okay, note that there are actually 4 main DLLs, mainly kernel32.dll, advpa32.dll, advapi32.dll, user32.dll, and ws232.dll. Okay, starting from kernel32.dll, we can actually look at the imported functions. There are many imported functions here, but let's take a note of a few, such as get environment strings, create process, sleep is like a backdoor kind of indicator, get process address, it also writes to a file. Yes, so for now that's about it for kernel32. Moving on to advapi, you can see that there's registry open key, registry set value, and registry delete. All these are actually registry functions that we can actually take note of. It's making registry operations. Next would be user32.dll. Okay, so there's nothing much for us to actually take note, so let's move on. Okay, WSA socket A is actually creating a raw socket, which means it's probably trying to connect to the internet. So yes, that's all for the 4 main DLLs. Okay, so there was nothing else for the 4 main, so let's actually look deeper. So for advapi32, it actually also calls kernel32.dll, so let's look into it. There's copy file, create file mapping, create event, create file, creating mutex for us to take note. So there's also finding next file and finding the next resources. Moving on, there's getting computer name. Same as what we saw just now, getting process address. Loading libraries. It means the malware actually searches a directory for a file or subdirectory. Moving file is making changes to the file directory. Mutex operations. sleepex is also another indicator of backdoors. Writing file. Yes, that's it for this. So advapi32 actually also calls out for ws232.dll. There are a few functions such as get address info and get name info to take note. So get address info actually provides protocol independent translation from an ANSI hostname to an address, which means it's probably also another indicator that the malware is actually trying to connect to the internet. Moving on, let's look at ws232 under NTDLL, where we can actually see strings like RTLLPv4 string to address. So this field actually indicates a function converting a string representation of an IPv4 address to a binary IPv4 address. Whereas this actually converts IPv6 string representation to IPv6 address of a binary address. Okay, so lastly, in order to gather more information about the malware that cannot be retrieved from the other analysis method that we went through just now, BinText can be used to run against the malware as an attempt to try and decipher some of the legible strings that is able to give us a deeper insight into the malware. So let's go to BinText and open up the file and press go. So let's actually analyze some of the strings. We can see that some are illegible, so let's just move on. Okay, so we are actually able to see some of the DLLs that were imported as what we see in dependency workers, and some of the functions that were caught and seen in dependency worker. So let's take note of some strings. User32.dll might actually be a DLL that was created by the malware, because this was the fault that we actually saw in the dependency worker. So we see create process, getting environment strings. So getting environment strings actually means it might be possible that the malware is actually trying to gain access to the variable of password stored in the current process. Whereas copy file, oops. Copy file might be a manipulation on a host system. It's a file manipulation. And create process A, it might be possible that the malware is actually trying to execute itself. So let's move on. We see strings like registry open in what we saw for dependency worker, registry operations. Registry manipulations on the host system. We see terminate process. It might be possible that the malware is trying to terminate or end a particular process. Next, we see write file. It might be possible that the keylogger malware is actually trying to write data, example user ID and password. Okay, so we saw WSA socket A, which we saw also in dependency worker just now, and now we can see this particular IP address. So this might be the address that perhaps might be the location of the malware backend server, whereas WS socket A is actually the socket that might be trying to connect to the internet, perhaps to send information. Okay, so that's all for our analysis on BinText. So this concludes our basic static analysis. I hope you actually learned something, and I hope you enjoyed our video. Thank you. Bye.